Alright guys, welcome to Math 0314. This is part 2 of 7.2. What we're doing here is we're going to figure out what the x-intercepts and what the y-intercepts are. They actually, the instructions from the previous video, they also ask to find the discriminant. So we'll talk about the discriminant, but if I'm going to find the x-intercepts, then part of the process of finding the x-intercepts is finding the discriminant. So might as well just figure out the x-intercept and the y-intercept. So, how do we figure out the x-intercept? So, remember the x-intercept is when y is 0, so this is just x squared plus x plus 2 equals 0. And so, f of x is y, just to be clear. What we're saying here is that, notice this is the coefficients here are 1 and 1. If there's not a number, it's 1. And what we're doing is we're going to use the quadratic formula to figure this out. So we're going to use negative b plus or minus square root b squared minus 4ac all over 2a. And we're just going to substitute in the values. Remember, a is 1, b is 1, and c is 2. So we have negative 1 plus or minus square root 1 squared minus 4, a is 1, c is 2. So you're just plugging and chugging into the formula all over 2a, and a is 1. One thing I didn't mention in the previous video that I think is a common mistake is this is all over, so everything is over 2. Sometimes I find students writing this. Where they just put over the square root, the fractions over the square root. It's over the whole thing, not just the square root. So be careful with that. It's just a common mistake that I see students make. So we're going to clean this up. So cleaning this up, we're going to get negative 1 plus or minus square root. So this is going to give me 8. So this is 1 minus 8 over 2. And this is going to become negative 1 plus or minus square root. 1 minus 8 is negative 7 over 2. We know that whenever we see a negative, that we want to put an I in front. If square root 7 could be broken down, I would. It can't. There's no perfect square root that lies inside 7 because 7 is, well, prime. So this is as far as we go. So these are my x-intercepts. Which, what it really means is that there are no x-intercepts, right? Whenever you see an I, that means that the whatever the picture looks like, now I don't know what our picture exactly looks like, but it's going to be floating here. It's going to be a parabola, it's going to be floating. There will be no x-intercepts because they're imaginary. Now, the next question is what is the y-intercept? And if you were watching the second video, this is a great, easy question. The y-intercept is just the constant, which is 2. Because if the y-intercept is when x are 0, so if both of those x's are 0, then you're just left with the only number left, which is 2. So hopefully that makes sense, and we're just going to move on to the next question. So we're solving for x here. It says use any method that you feel will get you to the answer. So I'm always looking for an easy way to solve this problem. I do not see a quick, direct way of solving it. So I'm just going to brute force this. What that means is that I'm going to FOIL this out. Now this is going to become x squared plus 6x plus 9. Want to stress that if you FOILed, that's fine. If you want to rewrite it as x plus 3 times x plus 3 and go x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9, with 3x and 3x together giving me 6x. That is perfectly fine. You can do that. I just simply square this value, that goes here, square this value, that goes here, multiply these together, and then double it. And when I say multiply them together and double it, that's because you're going to have it repeat twice. So just doubling it is going to give you the 6x. So I like that method. It's an easy way to do that. Let's recopy what we have left. All right, so now I'm going to go ahead and put together like terms. So I have x squared and x squared. That's going to give me 2x squared. I have 6x minus 9x, which is negative 3x, plus 9 equals 8. I'm going to subtract 8 and this gives me 2x squared minus 3x plus 1 equals 0. Now, we have to solve this, and it doesn't state what method to use. So, what my recommendation is always to try first. It may not work, but try initially to solve this from the chapter 4 method of guessing and checking. So we're going to go 2x and x, because 2x times x is 2x squared. The back has to be 1 and 1. This will give me 2, and this will give me 1. So if it gives me 2x and 1x, we know that that adds up to 3x. So if they're both negative, this works. So we can say 2x minus 1 equals 0, and x minus 1 equals 0, and then we'll solve. So plus 1, divide by 2, and x is 1/2. I hope that you're at a stage now that you can see that you add 1 over and then divide by 2, so you could jump directly to that. I wrote out all the steps to be clear, but you don't really need to. You can jump straight to that. This one, you just move 1 to the other side and you get x to be 1. So x is 1, x is 1/2, and those are your answer. Now, I'm not going to do this for the sake of time, but you could substitute those values back in here and check to see if it's true. It's a nice little thing to do. If it was a test, I would be doing that. But here, I think it's sufficient. So, do you have to use the quadratic formula every single time? No. Could you? Yes. And for like finals and whatnot, the method that you decide is the method you decide. You can use whatever method you want. So let's take a look at number 6. So number 6, again, if you have 3 different types of terms, then you want to move everything over to the same side. So I'm going to start number 6 by adding 2x to the other side. And this is going to give me x squared plus 2x plus 5 equals 0. And I could try, like in the previous example, I could try to factor it out. It'd have to be 1 and 5 because 5 is prime. I know it's not going to work because there's no way that 5 and 1 can get me back to 2. So this is not going to work by the guess and check method. So instead, let me rewrite the problem. I could complete the square, but personally, I think the quadratic formula is easier, so I'm just going to rewrite the quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. And I'm going to substitute in the values. So remember, a is 1, b is 2, and c is 5. So if we substitute in those values, we're going to get negative 2 plus or minus square root 2 squared minus 4 times 1 times 5 all over 2 times 1. So solving this, we get negative 2 plus or minus square root. This is going to be 4 minus 20 all over 2, which is going to give me negative 2 plus or minus square root negative 16 over 2, which if I keep going, because it's negative, we can take out an I, but the square root of 16 is 4. So let me actually write it out. It's going to look like this. But because the square root of 16 is 4, I have negative 2 plus or minus 4i over 2. And this breaks down to, because this is very important, because 2 and 4 are both divisible by 2, we can divide both 2 and 4 by 2. So 2 divided by 2 is 1, so this is negative 1, plus or minus 4 divided by 2 is 2, which is 2i. So we get negative 1 plus or minus 2i, and that's my final answer. Okay, in number 7, the intimidation factor is the fractions, but we've learned throughout this course, and I really do hope that this idea was the first thing that popped into your head, which is we're going to multiply through by the number that's going to get rid of 4, 2, and 3. So the way I figure that number is I start with 4, and I say, if I multiply through by 4, will I get rid of the fractions? And you would, except for the back part, because 4 divided by 3 is not going to go in evenly. So then I double 4, and I get 8. That's not going to work with 3. And so then I triple it, and I get 12. And that for sure is going to work. So I'm going to multiply through by 12. And we're going to multiply everything by 12. So 12 divided by 4 is 3. So we have 3x squared. 12 divided by 2 is 6. So minus 6x. And 12 divided by 3 is 4. And this equals 0. And so now, I'm going to always try to factor first. I do believe that factoring is the best method, if you can get away with it. 4 is interesting because 4 is going to work with either 2 and 2 or 4 and 1. I can see that. I can look at it and I actually can see that it's not going to work with either, but let me illustrate why. So this is going to give me 6x and 2x. Remember, the goal is with 6x and 2x. 3 times 2 is 6. 2 times 1 is 2. The goal is to get to 6. So there's no way with 6 and 2 I'm going to get to 6 because one of the numbers is 6. So that's not going to work. But even if I tried 3x, it'll say I put 4 here and x and 1. I'm going to get 3 and 4, and that's going to give me 7. Or it's going to give me 1. There's no way I'm going to get to 6. So that's not going to work. And if I flip it the other way, it's going to get way too big because I'm going to end up getting 12 and 1. So I can't factor this. So what I'm going to do instead, remember this is the value. Let me rewrite it. It's 3x squared minus 6x plus 4 equals 0. I'm going to go ahead and use the quadratic formula because that's what we've learned today. So negative b plus or minus square root b squared minus 4ac all over 2a. And we know that a is 3, b is 6, c is 4. Again, the big part about this is to pay attention to the signs. That's one of the biggest places students make the mistakes. If they make mistakes, a is 3, c is 4 all over 2 times 3. So, breaking this down, we're going to get 6 plus or minus square root. Let's see what happens here. So this is 36. This is going to be 12 times, interesting, 12 times 4 is 48. I thought it was 12 times 3 for a second there. I was like, that doesn't make sense. And I get 6. Let's keep going. So this is going to be 6 plus or minus, now 48 minus 36 is 12, but because it's the other way around, it's negative, over 6. Again, because we have a negative, we're going to go ahead and put an I on the outside. And 12, when you break 12 down, you're looking to take out perfect square roots. So this would be 4 and 2. And I've run out of space here. This is going to have to finish. I'm going to have to finish this now. So this is going to be 6 plus or minus. This is 2i square root 2. 2 because the square root of 4 is 2. Hopefully that's apparent. Over 6. Now, notice that 6, 2, and 6 are all divisible by 2. So to finish this, what I'm going to do is just that. I'm going to divide each of them by 2. So this is going to give me 3 plus or minus I square root 2 over 3. So 6 divided by 2 is 3, 2 divided by 2 is 1, and 6 divided by 2 is 3. And this would be my final answer. So you can see that if it doesn't work out nice, quadratic formula is the way to go. This last one is fantastic, and this is a nice little dessert after all this work here, because if you have only one term, doesn't matter if it's squared, cubed, whatever, the goal is to get everything else to the other side. And then once I do that, I have p squared equals 11 over 9. All I have to do is take the square root of both sides. And p is going to equal to square root 11 over 9. Now there's a couple things here. Number one, if we're listing all of the possibilities, then what I need to do is put plus or minus, because when you take the square root of p squared, you're left with a plus or minus solution. So this is plus or minus square root 11 over the square root of 9. I'm writing it like this because if I want to go one step further, I can. I can also say that this is p plus or minus square root 11 over 3. And this is just an issue of how the instructor wants you to write it. This is usually the way that people like to see it, the last step. But if you wrote plus or minus square root 11 over 9, that would be fine too. If it said write the principal root, then we would have just written the square root of 11 over 9. So lots of different ways of interpreting that, but this is pretty straightforward, at least algebraically. So this is it, guys. It's a nice little review of factoring and using the quadratic formula. Hopefully you were able to do all of these problems on your own. If you were not, then my advice to you is, now that you've seen me work through these, pause the video, go back through, and rework them on your own. In any case, let me know how you guys feel about this. You can send comments, emails, whatever is most efficient for you. And I will talk to you all in the next math video. Except I'm not actually done yet. Okay, so a couple things. I just finished rewatching these videos, and I noticed a couple little points that I want to make sure to be clear on. The first thing is I mentioned that, let me do this in gray here. This part right here is the discriminant, right? I had mentioned the discriminant. I was going to talk about it. What the discriminant tells you is the type of solutions that you have. So we got our answer to be imaginary, but we knew the answer was going to be imaginary because we got a negative value inside the square root. And when you take the square root of a negative, it's going to be imaginary. So if they had just said, hey, what are the types of solutions, I would have just taken the discriminant, solved that, and realized because I'm going to get a negative result, that it would be negative. So that was the first bit. The only other mention that I want to make about this is I made a silly mistake right here. The square root of 12 breaks down to square root of 4 times the square root of 3. I said 2, but I think what I was doing in my mind was I was thinking about the next step, which is that all these are divisible by 2. And so I was thinking about that. So this should be 3 and not 2. So a little mistake there. Again, got to emphasize, you got to go back through things and double check. Apologize for those little mistakes. But everything else seemed pretty good. So hopefully that makes this a little better. And now I will see you guys in the next math video.